professional educator.
Hello everybody, I am Ted Owiti and welcome to the third lesson on physics for the Form 4s. Now previously we talked about the characteristics of images formed by thin lenses. We talked about both the converging and diverging lenses. We also talked about linear magnification, and lastly we derived the lens formula and used it. Now, for today's lesson, we are going to determine the focal length of a converging lens, and we are also going to define the power of the lens, and we are also going to talk about application of the lenses. In determining the focal length of the lens, we have three ways to do this. The first one is focusing on a distant object, all right? And the second one is using a plane mirror. And the third one is using the lens formula. So we will start with the first one, which is focusing on a distant object. So in this case, the lens is mounted on a lens holder, and a distant object is focused onto a sharp screen by moving the lens to and fro until a sharp image is formed. So we have a setup like that one. And you can see we have a setup such that there is a lens between a window, which is showing objects that are beyond, and a screen. And so we move the lens to and fro so that we can get a sharp, clear image formed on the screen. And once the sharp image is formed on the screen, then we know how it behaves from our previous topic. This is a situation whereby the rays are coming from infinity. You can see that we have parallel rays that are coming from infinity, and the image is formed at F, which is from F to the optical center is our focal length. So the distance between the screen and the lens is the focal length of the lens. And this is because rays from infinity are converged at the focal plane. Remember, the focal plane is which is a plane which contains the focal point. The second way of determining the focal length of an converging lens is by using the illuminated object method. Now, in this method, what we do is we have a setup that has a cardboard with cross wires at the center, and then we have a source of light, and we have a plane mirror on the other side. So in between we have a lens. So the first thing that we do is we need to illuminate the cross wires by lighting the bulb. As you can see, our bulb has been lit, and the rays are coming from the object and they are hitting the lens, and they proceed on to the plane mirror. You notice that the if the object is at f, then the lens will refract the light parallel to the principal axis. Now, once the parallel rays from the lens hit the plane mirror, they are reflected back to the lens and a sharp image is formed on the screen.